Hello, my name's Stuart and I have a wee company called Bound by Starlight. I am an astronomer that likes to take pictures of the Scotland under the stars, and this is just a video showing you how I tackle the issue of trying to do deep space imaging while having something cool in the foreground. On the 16th of July this year, we are going to witness a partial lunar eclipse as it rises. So what I want to do is photograph a mountain in the foreground with this eclipsing moon in the background. So how I've got it is, this is a program, it's a really good program, it's free, it's called Stellarium. You can just grab that off the internet and it's really good for learning about the night sky and planning what you want to do. So there's our rough time where the moon is going to be rising. This eclipse is only going to last about 10 minutes, but the important information I want is the azimuth and altitude. So I know there's a lot of information here, but you see it says 376 degrees and it's going to be 2.5 degrees high in the sky. Is as time goes on, the moon will get higher and it will also change direction. So if I just move it a few minutes. So this brings me on to my problem and how I'm going to solve it. We have, there's Benim, and then I want to photograph Berniern, which should be in the path approximately. So what I need to do is figure out the exact trajectory of where the moon is going to lie. So I'm quite simply going to draw a line of where the moon's going to be at 0 when it is just risen. And I'm going to figure out where I need to stand on Benim to photograph Berniern. Okay, so give me a second and I'll draw that line. So here we go. I've drawn a line at 135 degrees, just simply using a protractor. Now, the important thing to notice is I'm using this trig point which is 126 meters off from sea level, and that really is important for where I want to stand on this patch of ground, which is just off to the path. Because if I stand lower than 126 meters, the moon will be in a different position. So what I want to do is figure out how high I want my mountain in the sky, so aka the height of the ground here, and just do some Pythagoras to get a degree angles that I can then put back into Stellarium and figure out at which position I want to be standing. So obviously I've got these rocky cliffs here that I've got to be careful of. So I'm probably going to sort of choose an area just close to this cliff and then recalculate my position of how high in the sky I want the moon. Okay, so let's give that a whirl. So just the first really basic thing I want to do is know how far away I am from my subject. So got Berniern and Benim, just got this X marked, so I am 9 centimeters away. If you didn't know, OS maps are scaled at 25,000, so it's just 9 times 25,000 will give me the distance I am from the mountain in centimeters. So, okay, so this is where practicality meets maths. You can see the little X that I've drawn is where we have 0 degrees between the horizon and the moon. I don't know what the ground conditions are there. It could be very marshy. Heather's really bad for setting up a tripod. So here is a really tempting point where the crosshairs intercept the path, because I know that's good ground to set up a tripod. So each of these lines is 10 meters down. So I calculate that line is about 870 meters above sea level for doing the other one. So I'll have a triangle that'll be about 56 meters in one axis and 2,250 meters in the other length. So that'll give us our angle of how high the mountain is going to be. We also at this point, when you're talking about sizes in astronomy and photography, sometimes it's actually really useful to talk in the degrees, as in the size of the angle it's going to take up in the image. So if you didn't know, the moon is at 31 minarcs. There's 60 minarcs in a degree. So we're talking the moon, its size is about half a degree. So we're going to want to add half a degree into our image so that we know that we can get the moon like in the photograph. Obviously I don't want the moon half behind the mountain, so I need to add about half a degree onto what we calculate here. So let's just run through the calculations and see where the moon, because remember as the moon gets higher, it's going to move further over left, and then I've got this big problem here of this cliff, because obviously I don't want to be anywhere close to this cliff in the middle of the night. So we're probably going to end up around about here, and then we're going to try see if we can calculate it to get it back on the path. So let's see how that plans out. So I have to confess I did a bit of an error. In the red line in the stellarium, the moon was actually 2 degrees in the horizon, not truly at 0. So when I then calculated the size of this triangle that we had made, I actually came to 1.4 degrees high, add half a degree onto that for the size of the moon, came to 1.9. So the red line was actually almost accidentally spot on. So just what I did was the green line, which I have added, is the position of the moon at true 0 on the horizon, and it does give you an indication of just how far the position has changed and how a small calculation in the degrees in rise leads to a large movement when you're talking about your position of where you need to stand to capture the image. So I'm quite happy now where that single line is on the path is where I'm going to plan to take the shot. So I need to remeasure the distance, and what I would like to do now is have somebody standing on the top of the mountain where the trig point is, silhouetted by the moon. So again, let's assume this person is 1.8 meters high. We need to figure out how big they are going to be in comparison to the moon. So let's try this. So here's just a shot of the moon from a while ago, and it's 30 minarcs in size, as we discussed, and this will kind of show you why it's really useful to talk about size in degrees, because if we take our 1.8 meter couple, they are actually 3 minarcs in size, which still does mean that the moon is rather dominating them. It will be quite, they won't be that noticeable. So I want to try and scale it. So if I had somebody who is 4 minarcs in size, it's going to be a much better composition. So what I now need to do is figure out what distance away from the couple I want to be to try and get them to the scale I need to be. Obviously, because the moon is so far away, moving around the planet Earth doesn't really substantially change the moon in size, but going a little bit further or closer to the people that you want to photograph on the hill will make a big difference. So let's try and prove that. So I calculated I wanted to be about 1.5 kilometers away from them, which is about 6 centimeters, which really does put me in the bottom of a gully. So if I went to here, which is 1 3/4, just standing on the edge of this cliff, I could get them to just about 3.8 minarcs, just standing on the edge of the cliff. However, I've come down, so I'm now only at 830 meters altitude, which means that the moon would have to be at, would only come visible at them at degrees, at an altitude of 3.9 degrees. Now there's two huge problems there. The first is this eclipse is only going to last about 20 minutes, so it'd be over by the time I was able to see the moon. And the second problem is it would bring me to, it would be about 140 degrees in angles. So if we just did that, took 140, which is going to be roughly there, which is just going to be guess this. I'm not going to draw it in because, as you can see, what's really happening is we're just ending up being well and truly, in the cliff where there is no ground. So it is not possible to make this couple appear larger than about 3 minarcs in the photograph, which is acceptable. I would have liked better, but it's good to use this method to know that I'm going to get the best possible photograph I can. I hope that's really been kind of informative for you, and yeah, I'm bound by starlight. You can check me out and contact me if you want to. Thank you very much. Bye.